So this problem asked us to write a system of equations. Remember, a system of equations has at least two equations that matches the given graph. So a couple different strategies you could do. One is we could find the solution to the system on the graph. And if you remember, solution means where the two lines intersect or where they cross. So I could find the solution. It looks like it's about 2, 3, but it's a little bit off. It's not exactly 2, 3. So I actually need to write the equation. If it were exactly 2, 3, I could plug in 2 for x and 3 for y into both of the equations and check that it equals what's given. But again, these are not exact, so I'm going to walk you through the process of writing the equation. So let's pick this last one. I'm going to take this equation and I'm going to solve out for the mx plus b, the slope-intercept form. So I'm going to rewrite it right here. I have x plus y equals 10. And I'm going to do that one first. I want to solve out for the y. So think to yourself, how would I solve for y? What would be my first step? I'm going to move over the x by subtracting. So I have x minus x is 0, so that goes away. I have y equals 10 minus x. And sometimes I like to rewrite this as y equals negative x plus 10. That way I can see my slope is negative 1 and my y-intercept or my starting point is 10. So let's double check on our graph, coming over here. Does my graph start up at 10 and have a negative slope of down 1 over 1, down 1 over 1? Neither of these lines do, so I know that actually this answer is not correct. So I'm going to go through that process again. Actually, you're going to go through that process again and solve out for the mx plus b, the slope-intercept form, of each of these equations to double check if they are the lines that are graphed.